On chapter 1, Introduction to Statistics, let's explain some more important terms in statistics. So, if the sample data are not collected in a proper way, meaning you do not pick a simple random sample, you collect the data in an inappropriate way, and the data may not be useful at all. So basically, you cannot use the data coming from the sampling method, which is not a proper method. The method used to collect sample data influences the quality of the statistical analysis. So the quality of the sample data actually is crucial to have a successful statistical analysis and come up with a proper conclusion. And simple random sample, that's a target goal, right? So if you conduct a survey, come up with a sample, simple random sample is desired, meaning in order to have a good result, you need to have a simple random sample. And we'll get to the definition of simple random sample later on. So two major statistical methods. First one is observational study. Second one is experiment. Okay. Those two are most important tools researchers used to conduct the research study. So let's get to the definition of the experiment and then observational studies. Observational study, basically researchers just observe and measure specific characteristics without attempting to modify. So you do not modify the subjects that are being studied. So this is very important concept embedded under the observational study, no modification needed. Okay, you just simply observe and then measure the specific characteristics of the participants. Okay, experiment. For the experiment, researcher will apply some treatment and then observe the effects on the subjects. So the subjects in the experiments are called experimental unit. Okay. So the Pew Research Center surveyed 2,252 adults and found that 59% of them go online wirelessly. So in this particular research study, researcher did not apply any treatment to the subjects. So this is a typical observational study. So they just collect the data, observe and collect the data from the subjects without modifying anything. So observational study. Okay. And another example, in the largest public health experiment ever conducted, 200,745 children were given the Salk vaccine, while another 201,229 children were given a placebo. So the vaccine injections consist of a treatment, right? So that modifies the subjects. So when you inject the vaccine into human body, you're actually making a modification to the human body. So here, this is typical experiment. Okay. So you can also say that there's a human intervention involved here. So this is experiment. Now let's get to one of the most important concept in statistics is simple random sample. Okay, so this is whenever you conduct a survey, simple random sample is required. So in order to guarantee the good result, you need to have a simple random sample. So the definition of a simple random sample, a sample of n subjects is selected in such a way that every possible sample of the same sample size, have the same chance of being chosen. And if you look at this, this is very rigor, or very strict, and then it's also very extremely difficult to guarantee. So that will make sure you have a really good sample, then the result will be in a very random sense. Okay. And And the Brendas sample, so all the members from the population have an equal chance being selected, right? So every single member in the population has an equal chance being selected. Okay. So again, compared to the simple random sample, this is less rigor. So simple random sample is much better compared to random sample. Now let's talk about a sampling method. Since we talk about sampling method is also an important process in terms of the whole statistical analysis. So the first method is what we call systematic sampling. So you select the starting point. So in the entire population, you pick a starting point and then select every kth element in the population. So in this case, assuming this is the population, now for our sample, we are picking every third member. Okay, pick a starting point. This is starting point. And from there, we pick in every third member after starting point. And this becomes our sample. Okay, and this is what they call a systematic sampling method. You can pick every kth member, right, in the entire population. If you have a fairly large population, you can pick every 10th, 20th, maybe every 1,000th members in the population. Depends on the population size. And the second method, sampling method, is what we call convenience sampling. So we use a result that are easy to get. For example, if you live in a building and you conduct a survey and you collect data from your neighbor, right? You collect data from the neighbor, then this is convenience sampling from the neighbor. Okay, so this is typical convenience sampling. Also, if let's say you're running a radio station and you collect data from your own audience. So radio station collecting data from its own audience. This is also a convenience sampling method. And definitely it's very easy to get the data because you're just getting data from your own audience. And the third method is called stratified sampling. So basically you subdivide the entire population into at least 2 different subgroups. So for example, if you look at the population of US citizens, you can divide into male and female, or women or men, and then you're picking draw the sample from each subgroup, meaning you're picking a sample from the women group, picking a sample from the men group, and then put them together, and that becomes the general sample you pick. So you can definitely just subdivide the population into at least 2 different subgroups, okay, to get a stratified sampling result. Also cluster sampling, so divide the population area into sections or clusters, and then randomly select some of those clusters, some of those sections, and then choose all members from selected cluster. For example, if let's say you look at New York City and you have look at all the precincts in New York City, and you just randomly pick precinct 5, precinct 16, and precinct 28, and you select all the residents from each precinct and then come up with a sample. And this is a typical cluster sampling. Another example could be if you want to survey the New York City residents, you could divide into 5 boroughs, right? 5 boroughs, and you pick let's say you use Manhattan and Brooklyn and then collect data from every resident from Manhattan and Brooklyn, and use that to represent New York City. And that's also what we call a cluster sampling. And sometimes in the complicated, research study, you may collect data based on different stage, and by combining different sampling methods. So at a certain stage, you probably feel like a certain sampling method is better off. So at a stage 1, stage 2, you're picking different stage 1, stage 2. For example, stage 1, you could pick cluster sampling method. And maybe stage 2, you're picking systematic sampling method. And depends on the need. Definitely, you could come up with different kind of sampling method. Stage 3, maybe you're picking stratified sampling method. So totally depends on your research, objective. And definitely you can use different sampling method to conduct a research study. So basically, this is summary what we talk about so far. So sampling methods, first one random sampling method, second one systematic random sampling method, third one is convenient sampling method, fourth one stratified sampling method, fifth one cluster sampling method, sixth one is more like comprehensive ones using multi-stage sampling method. Okay. And anytime you conduct a research study using a sample, there's always an error involved here. No matter how well you plan and execute the sampling collection process, there's likely to have some error in the results. First error comes from the sampling error, and this is also the systematic error, meaning you cannot avoid it, right? Non-avoidable error. So no matter how good your sample is, you can pick simple random sample, but the difference between the sample result and true population result still exists. So this is typically coming from the system, because no matter how good your sample is, it's never as good as the population itself. So that's why there's a minor sampling error occurring in the sampling process. And also we have non-sampling error, and this is what we call, this is avoidable. You can avoid the non-sampling error. It's also called human error. That's why you can avoid it. Just being more careful, and then follow the procedure more carefully, and record the data properly. Then you can avoid the non-sampling error. So non-sampling error occurs when the sample data incorrectly collected, recorded, or analyzed. So, for example, if you could come up with a non-sampling error by selecting a biased sample, meaning you're not picking a simple random sample, you're picking a biased sample. Maybe it's you just pick a convenient sample you could use a defective instrument or copying the data incorrectly. These are all human errors, and you can avoid the human error, avoidable. Okay, so two types of error. And also we have a non-random sampling error, meaning when you pick the sampling method, you didn't pick a proper sampling method, or maybe you just use a convenient sampling method or voluntary response sample, which is not a good sample. Then non-random sampling error occurs, meaning the sample is not simple random sample, then that's bound to have some non-random sampling error.